Kirchhoff's law. These laws are useful to find out the voltages and the currents in circuits. There are two types, that is Kirchhoff's voltage law known as KVL and Kirchhoff's current law known as KCL. KVL states that the algebraic sum of all the branch voltages closed path in a circuit is always zero at all instants of time. Considering a circuit we have Vs voltage and V1 is the voltage, and the voltage drop across the resistance R1 is given by I R1, and the voltage drop across R2 is given by I R2. Now consider the current is always going to flow from the positive end to negative end, but whereas it is flowing from negative to positive, so I am considering Vs as negative. So here also I am considering minus V1. Then here the current entering positive and negative, so plus I R1 plus I R2 equals to 0. Vs plus V1 equals to I R1 plus I R2. I R1 plus R2 nothing but Vs plus V1. Then we can find out the current I by Vs plus V1 by R1 plus R. KVL is applied for closed loop circuit. This can be used for mesh or loop analysis to find out currents. Kirchhoff's current law states that the sum of the currents entering into any node is equal to the sum of currents leaving that node. Node is nothing but the interconnection between the two elements. If only two elements are connected, then that node is known as simple node. Three or more than three are connected at a node, then that node is known as principal node. Considering a node, the currents I1 is coming in, I2 is going out, I3 coming in, and I4 also coming in, and I5 going out. According to the Kirchhoff's current law, that KCL, that algebraic sum of the currents at a node is equals to 0, or the currents entering into the node is equals to current leaving the node. So current entering into the node is I1 and I3 and I4. So I1 plus I3 plus I4 is equals to leaving node is I2 plus I5. KCL is going to work on the basis of nodes. So KCL is applied for node analysis. And these are the statements for KVL and KCL. Circuit elements are in series. The voltage drop here is V1, and here it is V2, and here it is V3. If elements are resistances, R1, R2 and R3 are connected in series. Applying the KVL, this is V minus V1 plus this is V2 plus V3 equals to 0, or V equals to V1 plus V2 plus V3. V is H is given by the current I, and the resistance of the total circuit RT is equals to the I1 R1 plus this is I R2, V2 is I R3, these are V3. And write I of R1 plus R2 plus R3 is equal to I RT, total resistance. RT is equals to R1 plus R2 plus R3 if the elements are parallel. This is I, here it is I1, in this branch this is I2, and this branch this is I3. If the elements are resistors R1, R2 and R3 are connected in parallel, then applying KCL at the node, incoming current, that is I, is equals to the outgoing currents, that is I1 plus I2 plus I3. I is nothing but V bar, that is the total voltage divided by the total resistance. I1 is given by V by R1 plus, at this node also voltage is V, so V by R2 plus V by R3 and so on. by RT equals to 1 by R1 plus 1 by R2 plus 1 by R3. RT is the total resistance. If the elements in the circuit's inductors, that is L1, L2 and L3, then we know the formula of KVL for an inductor. V equals to L di by dt. V1 equals to L1 di by dt. V2 equals to L2 di by dt. And V3 equals to L3 di by dt. Now if you substitute this, then you are going to get L equals to L1 plus L2 plus L3. Equivalent or total inductance of the circuit, the elements L1, L2 and L3. I is given by 1 by L integral V dt. Similarly, I1 is given by 1 by L1 integral V dt. And the I2 is given by 1 by L2 integral V dt. If you apply the KCL, you are going to get 1 by L equals to 1 by L1 plus 1 by L2 plus 1 by L3. This L is nothing but the total inductance. If elements are capacitors, that is C1, C2 and C3 here, voltage is given by 1 by C integral I dt. V1 equals to 1 by C1 I dt. Then V2 equals to 1 by C2 integral I dt. And V3 equals to 1 by C3 integral I dt. Then if you substitute on this, then you are going to get 1 by C equals to 1 by C1 plus 1 by C2 plus 1 by C3. This capacitance is nothing but the total capacitance or equivalent capacitance of a series capacitive circuit. Here, if the elements are capacitors C1, C2 and C3, current is given by C dV by dt. Then I1 is given by C1 dV by dt. I2 is given by C2 dV by dt. I3 dV by dt. And substituting this, you are going to get C equals to C1 plus C2 plus C3. This is nothing but the total capacitance of a parallel circuit having capacitors C1, C2, C3. Voltage division. The series circuit acts as a voltage divider since the same current flows through each resistor. The voltage drops are proportional to the value of the resistors. V1 equals to what is the factor of the resistance R. So R1, I1, V2 equals to R2, I2. Similarly, if you write Vn equals to Rn, I, N. But we know that in a series circuit, I1 equals to I2 equals to In. By applying KVL, we can write the current I is given by the source voltage Vs divided by the total resistance, that is R1 plus R2 plus R3 and so on for n. Vn is equals to, we have Rn and multiplied by In. In is nothing but total current I. So I, that equals to Rn Vs divided by R1 plus R2 plus R3 and so on Rn. Vn equals to Rn divided by Rt, total resistance, multiplied by the source voltage. Vn is the voltage across the Rn. From this, we can say the voltage drop across the Rn is given by the resistance Rn divided by the total circuit resistance Rt multiplied by the source voltage Vs. Current division. In a parallel circuit, the current divides in all the branches. Thus, parallel circuit acts as a current divider. The total current entering into the parallel branch is divided into the branch currents. We have two branches, R1 and R2. Then the current flowing through R1 is I1, current flowing through R2 is I2. I1 is the current which is given by Vs by R1. I2 is equals to Vs divided by R2. The total current Is is given by Vs by R total. 1 by RT equals to 1 by R1 plus 1 by R2. But the total resistance is RT, that equals to R1 R2 divided by R1 plus R2. Substitute this Vs multiplied by R1 plus R2 divided by 1 R2. This Vs equals to Is multiplied by R1 R2 divided by R1 plus R2. I1 equals to Is R1 R2 divided by R1 plus R2 divided by R1. R1 gets cancelled. You are going to get Is R2 divided by R1 plus R2. The current in any branch is equal to the ratio of opposite branch resistance to the total resistance value multiplied by the total current. Power in series circuit. The total power supplied by the source in any series circuit is given by Ps equals to the sum of the powers in each element, that is P1, P2 and so on, Pn. Vs, Is equals to I square RT Vs square by RT, where Vs is the total voltage applied, Is is the total current, and RT is the total resistance of the series circuit. Power in parallel circuit. Total power PT is given by the total voltage and the total current equals to I square RT, if it is resistive, equals to Vs square by RT.